This is Grook. He lived sometime in negative millions of years ago. Grook is an average bloke, he hunts deer, he runs around, and loves cave women. Preparing for a moose hunting session, Grook picks up a rock. There's nothing special about this rock, it could clobber a good moose. Then, something revolutionary happens. Something so mind-blowing that it changed the world forever, a spiral which has created science, engineering, and logic itself. Grook picked up another rock, but instead of saying, "Me have a rock and a rock," Grook says, "Me have two rock." And just like that, Grook unleashed the beast of number theory and mathematics itself. Early humans used their fingers to count. One apple means one finger up, two apples means two fingers up. Did I really have to explain it to you? It's likely that counting was the first sign language ever invented, which is a big loss to all the deaf cavemen out there. They could only count at each other. That's good up to 10. Okay, I lied, it's actually good up to 1,024 numbers, but come on, you know it's 10. And humans are big boys now and need to count, I don't know, the moon, I guess, which happens to be in cycles of 30 days. I have an idea. Let's put numbers under our hands, or at least under animals' hands. Tallies were counted on bones 40,000 years before writing was ever invented. It's negative 4,000 now. Society was built, clay was harvested, and the Babylonians made these things. What a mess. They could only count ones and tens, way faster than on hands, but I mean ask them to write down, 3,051. Yeah, nice try guys. At least they kickstarted writing from all their accounting nerd purposes. That's right, all you number crunchers, you made writing. Okay, enough fun, get back to my taxes. 1 is good and 2 is good, but 1.5? What are you talking about? Around the same time the ancient Egyptians realized you couldn't give 1 pie to 2 people, or actually a bird or a rat or something. They had an even better way to write numbers, but still awful. What am I looking at? They used this symbol for putting a number on the bottom and only used whole reciprocals, except for 2/3 and 3/4 who are apparently special. But what about 5/7 or 8/9? Don't worry my friend, just add together different reciprocals. According to this, you can always make your fraction. Yeah, good going guys. But through a bunch of different systems, fractions were kind of figured out. Not really, but hey, the Indians got pretty close to the modern day. Those are nice. Almost too nice, as if they're rational, like a ratio between 2 numbers. What if you don't need this ratio? What? Why would you want that? Maybe to find this or this, which could be useful for, I don't know, building stuff? The classical Indians even put them in this book, but it says here that root 2 is about 577 over 408. What? That's not irrational at all. Look, you can never express an irrational number as a perfect nice way for humans to understand it. That's what happens when you have infinite decimal points. The first guy to realize this fact was someone called Pythagoras. He was the first guy not to try to blindly solve root 2, but instead say, you know what? You can't do it, except with more logic behind it. Another Greek nerd, Theodorus, made a cool looking spiral and proved irrationality among 12 more roots, even getting root 3 named after the boy. You know what's even better than Greek maths? Roman maths. You see that they made yeah, never mind. The Romans used strings of letters of value 1, 5, 10, 50, 100, 500, 1,000, up to 1,000,000 to make up their numbers. But the order highly matters, so IV is 4, but VIII is 8? What? And this number is, yeah, I don't know either. Pop quiz for you, Julius. What is this minus this? Yeah, I thought so. And sadly, the Romans made a huge empire, which meant that their numeral system lasted in Europe for another 1,000 years. Truly awful. Ugh, I need to clear my head from that. Let's just sit and think for a while. At least that's what Aristotle did, and he thought about something big. Really big. Infinite even. This wasn't really a mathematical discovery, but more of a philosophical one. And oh boy, it sure sounds like one. He made up actual infinity, entities with completed objects, and potential infinity, which is a non-terminating process, which, okay man, that's cool. And around the same time, Jain mathematicians in India were loving infinity too. They even had 5 types: infinite in one direction, infinite in 2 directions, infinite in area, infinite everywhere, and infinite perpetually. What the were they smoking? What about something even crazier? Yet another Greek, Diophantus, thought up an equation that was basically 4x plus 20 equals 4. If you've taken math up to the 7th grade, you'll see that it equals negative 4? Diophantus thought this was absurd, and everyone agreed, except for the Chinese in this book. They used negative coefficients to find certain areas. Negative numbers were basically only used to calculate debts from that point on, which is actually what I'm in right now. Both European and Indian mathematicians would sometimes just throw away negative results until the last few centuries. What inspirations. We got pretty much all the numbers on this number line, but we're missing one. You see that guy in the middle? Their name is 0, and you're probably thinking, blah blah blah, how could they forget 0? It's so important. But the Greeks who love new numbers said it themselves. How can nothing be something? Well, they didn't think like that in India, and in 628 AD, Brahmagupta made this new book called It's Not Important. It made our modern understanding of 0 and negative numbers, and no one ever used 0 anywhere else except for maybe the Romans, Olmecs, Babylonians, Egyptians, Khmer, Chinese, Arabs, Sanskrit writers, medieval Europeans, and anyone else used as a placeholder for a number like 10. But yeah, Brahmagupta totally invented a whole number. If you think of 0 like this, it may be because you use the best numeral system out there. No offense, Romans, but let's go through some honorable mentions. Chinese numerals, so fun, they literally just use characters to represent numbers. Just kidding, that's lame, but they did use these cool counting rods. Bengali numerals, 8 for 4 and 9 for 7. This is madness. It actually works exactly like our system, but it's squigglier. Hebrew numerals, why invent a new alphabet when you can just use your own? With Hebrew letters and dashes, they make all the numbers they need. And Maya numerals, all you need are rods and dots, which makes adding small numbers super easy. I only missed about 100 other systems, but there can only be one winner. The real GOAT is Hindu Arabic numerals, or actually any system that has digits 0 and 1 to 9, like all of these. Out of all of them though, these came out on top. Starting in India, Arabic traders found them and loved them. The Arabs also love to trade and tell everyone, yeah, we made these. Who cares who made them, because now all of Eurasia is using them. The Europeans were gradually converted, but after the trendsetter Fibonacci started using them, it was all the rage. And the Chinese were introduced about 1,000 years before they finally gave in and used them. Is it a coincidence that India, the Islamic world, and the Europeans had a golden age of mathematics after adopting the 0 to 9 system? Absolutely. Actually, I don't know. Hundreds of years pass and nothing happens, until some apple falls on this guy's head. Naturally, he then came up with physics and calculus. Calculus scares a lot of people, but it's really just the math of the infinite. Adding to infinity, but smooth, or even smoother actually, an instantaneous rate of change. If you're in calculus, you hear that and you just put a straight line on a curved one. But if you unblock the non-ascended part of your mind and you hear instant rate of change, it makes absolutely no sense. That means there has to be something infinitely small. Newton and Leibniz pioneered the concept of an infinitesimal, usually shown as dx or dy or d anything really. Is something something when it's basically 0? You tell me. Congrats! We finished all the numbers and even threw in some concepts along the way. Now there's nothing else for us to do. Except make up new numbers. Some Italian boys made up formulas for 3rd and 4th degree polynomials, basically mega quadratic formulas, and realized that you'll get some crazy numbers out of them. Square roots of negative numbers. Do it. Find the square root of -1. Solve this. You can't. At least not with our numbers. Just make the square root of -1, let's say I. Rene Descartes called these new numbers imaginary, less of a, oh that's cool like a unicorn imaginary, and more of a, you're delusional if you believe in these imaginary. Although the nicer term nowadays are complex numbers. They come in so many flavors, adding a new axis to the number line. Are you team imaginary or complex? For all the keen viewers out there who've been watching, you may have noticed something missing, a number every person, even kid knows. That's right, it's pi, 3.14 blah blah blah. OMG, I can't believe you forgot it. After all, isn't that like the ratio of a circle's circumference to its diameter? You're right, but you're not thinking rational. Or at least, pi isn't. even though almost every ancient people found something close to pi, like 22/7, 25/8, or the square root of 10, no one proved that it was actually irrational until Johann Lambert did it in 1761 because of this. Not only that, pi is even more special than it thinks with all the attention it gets. Pi is transcendental, which means it spans the whole continent. No, that's not it. It means it can't be written algebraically or as a solution to any polynomial. Joseph Louisville essentially birthed this branch of number with the Louisville constant. Most numbers are transcendental, but we only really care about two, pi and e. But what's e, other than the most used letter in English and the least used letter in Mandarin? It's a constant 2.7 blah 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 named by Leonhard Euler, of course named after him. But it is essentially an infinitesimal over 1 multiplied by itself infinitely many times, or defined like this or this, and mathematicians love it because it's very natural and shows up literally everywhere in math. It's like a cat that always shows up when you least expect it. Congratulations, we made it through all the realistic numbers you'll actually use. Of course there are more, it's math after all. You can sort them, you can make your own sorters, put numbers in a square, count infinities, go hyper complex, go p-adic, or of course, there's a whole world of important constants in numbers. Why don't you study hard for a PhD in accounting and create some new numbers for the world to use?